Welcome to Ask and Learn.
This problem, we're going to talk about uniformly accelerated motion. And what we're going to need in order to talk about it is to remember that the acceleration is equal to the variation in velocity divided by the variation in time, and that the position x of a particle that's undergoing uniformly accelerated motion is equal to the initial position v0 plus the initial velocity v0 times the time delta t plus the acceleration times delta t squared over 2. Okay, and I'm going to define the distance traveled by the particle as x minus x0. So the distance d is equal to v0 delta t plus a delta t squared over 2. Remember that since the acceleration is delta v divided by delta t, then delta t is the acceleration, actually delta v divided by the acceleration. So we have that d is equal to, and actually, before carrying on, I want to remind you that delta v is v0 minus v minus v0. So we have that d is equal to v0 times v minus v0 divided by a plus a times v minus v0 divided by a squared divided by 2. So d is equal to v minus v0 over a times v0 plus v minus v0 over 2. So d is v minus v0 times v plus v0 over 2a. Finally, d is equal to v squared minus v0 squared divided by 2a. Okay, so this is what we're going to use. So suppose that you're driving at night at a speed of 20 meters per second, and you see a deer that's located 35 meters away from you, and your reaction time, that is the time that it takes for you to step on the brakes, is 0.5 seconds, and the maximum deceleration of the car is 10 meters per second squared. So the minimum acceleration is minus 10 meters per second squared. Okay, and in question A, we have to find out what is the distance between you and the deer when you stop the car. So let's see how much you drive after you see the deer. So the deer is 35 meters away from you when you see it. It takes 0.5 seconds for you to realize that deer is in front of you and step on the brakes. So the time, the distance traveled, I'm going to call it delta x1, is equal to your speed times t. So it's 20 meters per second times 0.5 seconds, and this is equal to 10 meters. After you step on the brake, your distance will be equal to the speed squared, actually minus the speed squared, since the final speed is equal to the final speed is equal to 0, and then I have to divide it by 2 times the acceleration. So we have minus v0, v is 20 meters per second, divided by 2 times the acceleration, that's minus 10 meters per second squared. So delta x2 is equal to 20 meters. Okay, so the total distance you travel is delta x1 plus delta x2, so that's 10 plus 20, which is equal to 30 meters. Since the deer was 35 meters away from you, then the distance between you and the deer, I'm going to call it L, is equal to 5 meters. Then in question B, we have to see what is the maximum speed that you can have so that you still won't hit the deer. Notice that delta x1 is the same because it's the time that it takes for you. So actually, I just misspoke. The delta x1 is not going to be the same. That delta x1 is the new speed v prime times the reaction time, that's 0.5 seconds. Delta x2 is equal to v prime squared over 2a. There's a minus sign here, so it's v prime squared over 20. Okay, so we have that delta x1 plus delta x2 must be equal to 35 meters. So we have that v prime squared divided by 20 plus 0.5 v prime minus 35 is equal to 0. Now we want to solve this, and we're going to solve it by using the Bhaskara equation. So we have a v prime squared plus b v prime minus c is equal to 0, where a is 1 over 20, b is 0.5, and c is, it's plus c, so c is minus 35. And v prime is equal to minus b plus or minus the square root of b squared minus 4 times a times c divided by 2 times a. So v prime is equal to 21.9 meters per second, or minus 31.9. And if we stick with the positive velocity, we get that this is the maximum velocity possible.